Okay, so sampling theory, right? Chapter number 2. When it comes to sampling theory and estimation theory, our next chapter, you should able to know the difference between these two, parameter and statistics, right? You should able to differentiate between these two terms, parameter and statistics. Parameter කිව්වොතින් මොකක්ද එතනින් mean වෙන්නේ, statistics කිව්වොතින් මොකක්ද එතනින් mean වෙන්නේ, right? When it comes to parameters, right? When it comes to parameters, it talks about, right? It talks about the population, right? It talks about the population, right? Population in the sense, the characteristics of the population. Population එකේ characteristics කියන්නේ මොනවද? Population එකේ mean එක, right? Population එකේ variance එක, ඔය වගේ population එකට අදාළව අපි කැල් කරලා ගත්ත එක එක දේවල්. Population එකේ standard deviation එක, right? Not only these three, right? There can be more. Anything we have calculated in terms of our population, we can identify as the parameters, right? Parameter කියලා කියන්නේ ඒකයි. Population එකට අදාළ characteristics තමයි අපි parameters කියලා හඳුනගන්නේ, right? Then now you know statistics මොකද්ද, right? Statistics means the characteristics we identify in terms of the what? In terms of the sample, right? Sample එකකට අදාළව හඳුනගන්න characteristic නැත්නම් measures. For example, mean, right? Median, variance, standard deviation, those stuff are we called statistics, right? Parameters are statistics වල වෙනස. Parameter නම් population එකකට අදාළව හඳුනගන්න characteristics. Statistics නම් sample එකට අදාළව හඳුනගන්න characteristic, right? In chapter number, during the last session, what we have discussed, අපි අන්තිමට කතා කරේ මොකක්ද? Normal distribution. Normal distribution වල මොන type එකේ ගණන්ද අපි හැදුවේ? Normally distributed කියලා දෙනවා, mean එක දෙනවා, standard deviation එක දෙනවා, ඊට පස්සේ අපිට එක එක criteria දීලා අදාළ probability එක අහනවා, right? The example we have done, can you remember? Mean packet එකක බර gram 400යි, right? Standard deviation එක gram 6යි. එහෙනම් packet එකක බර gram 412ට වඩා වැඩි වෙන්න පුළුවන් සම්භාවිතාවය කීයද? packet එකක බර gram 390ට වඩා අඩු වෙන්න පුළුවන් සම්භාවිතාවය කීයද? Right? Those type of questions were there under normal distribution, right? එතෙන්දී අපි හිටියේ මෙන්න මේ box එක ඇතුලේ විතරයි, right? මේ population කියන box එක ඇතුලේ ඉඳගෙන තමයි අපි ඒ ගාන හැදුවේ. Population එකේ mean එක දෙනවා, population එකේ standard deviation එක දෙනවා, population එක ගැනම එක එක criteria දීලා අපේ probabilities අහනවා, right? So we were here when discussing about normal distribution, right? Under sampling theory, what we try to do is we try to make conclusion about the sample, right? මේ population එකකින් ගන්න sample එකක් ගැන population එකේ characteristics දිහා බලලා එක එක conclusions වලට එනවා, right? I will say it again. Based on the population characteristics, we try to arrive at some conclusions about the sample which is drawn from the same population. මේ population එකකින්ම ගන්න sample එකක් ගැන මේ population එකේ characteristics දිහා බලලා අපි conclusions වලට එන එක තමයි what we have to discuss under sampling theory, right? Sampling theory. Can you understand what is here, right? මේ තියෙන central limit theorem කියලා තියෙනවා, එක එක formulas තියෙනවා, right? I hope you have already read those things, right? Right? What is this? Right? Right. So I think we can start with examples. You already know these things, right? Minimum slides to in slide number 2, 3, 4, slide number 2, 3, and 4 වලින් තියෙන එක summarize කරතින් it's like this, right? When it comes to population mean, how can we represent population mean? We population mean එක පෙන්නන්නේ කොහොමද? What? Using this one, right? Using mu. Using mu, we can represent, right? Using mu, we can represent the population mean, right? Population එකේ මධ්‍යනාගය අපි පෙන්නන්නේ mu වලින්, mean වලින්, right? මේ population එකෙන්ම අපි sample එකක් ගන්නවා, right? මේ population එකෙන්ම sample එකක් ගත්තට පස්සේ sample mean එක, right, we assume will be equal to the population mean, right? If we draw a sample from the population, from the same population, we assume that the population mean will equal to, right, will equal to sample mean x bar, right? That is one assumption. Central limit theorem කියලා කියන්නේ ඔන්න කතන්දර, right? Population එකෙන් sample එකක් අපි කඩලා ගත්තොතින් මේ population එකේ mean එකයි sample එකේ mean එකයි සමානයි කියලා අපිට assume කරන්න පුළුවන්, right? But the issue is with the standard deviation, right? Standard deviation. Population is standard deviation, right? This is the symbol we are using. When it comes to the sample, though we can assume the population mean and the sample mean are the same, we cannot assume the population standard deviation will be equal to the sample standard deviation, right? Population එකේ mean එකයි sample එකේ mean එකයි සමානයි කියලා assume කරාට අපිට බෑ population එකේ standard deviation එකයි sample එකේ standard deviation එකයි සමානයි කියලා assume කරන්න. Therefore, we need to do certain adjustments, right? We need to do adjustment to this one, right? මෙයාට adjustment එකක් කරලායි අපි ඒක sample එකේ standard deviation කියලා consider කරන්න වෙන්නේ, right? The adjustment we are doing is, right, whatever the population standard deviation, we are going to divide by, right, we are going to divide by this one, simple n. What do you mean by simple n? Capital N කියලා ලිව්වොතින් අදහස වෙනයි, simple n කියලා ලිව්වොතින් අදහස වෙනයි. Simple n කියලා ලිව්වොතින් what do you mean by that? Right? Simple n means the sample size. මෙන්න මේ population එක කඩලා ගත්තේ sample එකේ item කීයක් තියෙනවද කියන එක, right? The square root value of that. Right? If it was capital N නම් මොකද්ද? හරි sample size නම් මෙයා population size, right? Population එකේ item කීයක් තියෙනවද කියන එක capital N වල. Right. For this one we can give a name, right? This is we call the standard error of mean, or in shorter form we can write it as SE, right? Standard error of mean formula. This one, right? Standard error of mean. Right. There is another standard of error mean formula. right? Standard of error mean keyword passe. Either we can use the first one or we can use this one as well, right? Into square root of n minus n minus 1, right? ඔන්නෝම formulas දෙකක් අපිට තියෙනවා standard error of mean කියද්දි, right? So how can we decide whether we can use the first formula or the second formula? මෙයාවද පාවිච්චි කරන්නේ මේ formula එකද පාවිච්චි කරන්නේ කියලා? How can we decide, right? How can we decide, right? Standard error of mean, right? There is one formula, and here also this is standard error of mean, right? That is standard deviation of the sample mean. Both are the same. Usually we call it as standard error of mean, SE, right? How can we decide whether we are going to use the first formula or the second formula, right? That one, right? So here, when it comes to mean, we can assume both sample and population mean are the same, right? But when it comes to standard deviation, right? Population standard deviation may not be equal to sample standard deviation. Therefore, we need to do certain adjustment. After the adjustment, the name we can give is standard error of mean, right? When it comes to standard error of mean, there are two formulas, right? There are two formulas. In special occasions, so in special situations or circumstances, we can use these two formulas, right? For an example, this one. මෙන්න මේ දීලා තියෙන formula එක අපිට පාවිච්චි කරන්න පුළුවන් if there is infinite population, right? Infinite population. Infinite population, right? And the second formula we have to use if there is a finite population, right? අපේ මෙන්න මේ sample එක ගන්න population එකේ item කීයක් තියෙනවද කියලා දන්නේ නැත්තම්, right? If we are not known about the population size, right? Capital N value එකක් අපිට ගන්න කියන්නේ නැත්තම් ඒක infinity, right? ඒ වගේ වෙලාවක to calculate standard error of mean, we have to use this formula, standard deviation divided by square root of sample size. But when there is a finite population, again, අපි මේ sample එක ගන්න population එකේ item කීයක් තිබ්බද කියලා අපි හරියටම දන්නව නම්, නැත්තම් capital N value එක අපි දන්නව නම්, right? Then to calculate standard error of mean, we can use the second formula, right? So that is the difference between the first formula and the second formula, right? So, right, clear? Parameters, statistics, the වෙනස් වෙන population, the sample the කියන එක මත, right? The central limit theorem talks about this. Population mean we can assume as the sample mean as well. But when it comes to standard deviation, we have to do certain adjustment. If there is an infinite population, we can use formula number 1, or if there is a finite population, we can use formula number 2 to calculate the standard error of mean. Right. Right. You will understand with this. You will understand this one with an example, right? Example number 1. example number 1 වල මොකක්ද කියන්නේ? Right? A firm manufactures electric light bulbs that have a length of life that is approximately normally distributed. මොකද්ද මතක් වෙන්න ඕන? A firm manufactures electric light bulbs that have a length of life that is approximately normally distributed. සාමාන්‍යයෙන් බල්බ් එකක ආයු කාලය ප්‍රමතව ව්‍යාප්ත වෙලා ගිහිල්ලා තියෙනවලු. So we have an idea about the distribution or the shape of the distribution, right? Shape එක ගැන දැන් අපිට idea එකක් තියෙනවා. With the mean equal to 800 hours and a standard deviation of 42 hours. මේ මොනවද දෙන්නේ? Parameter the statistics ටික. Right? With the mean equal to 800 hours and a standard deviation equals to 42 hours. Parameter characteristic ටික දෙනවා. Right? Population එකේ mean එකයි population එකේ standard deviation values දෙනවා. Then find the probability that a random sample of 16 bulbs on ඔතනින් තමයි normal distribution එකයි sampling theory එකයි වෙනස් වෙන්නේ. Normal distribution වල මේ sample එකක් ගැන කතා කරන්නේ නැහැ. But when it comes to sampling theory, we should know the sample size. Sample size එක අපි දැනගෙන ඉන්න ඕන. Right? Find the probability that a random sample of 16 bulbs will have an average life less than 775 hours. Population එක දිහා බැලුවොත් mean එක 800යි standard deviation එක 42යි. ඔය population එකෙන් 16ක sample එකක් ගත්තොත් ඔය bulb 16න් අපි එකක් අහම්බෙන් ගත්තොත් ඒකේ ආයු කාලය පැය 775ට වඩා අඩු වෙන්න තියෙන සම්භාවිතාවය කීයද? Right? That is what we need to find. Right. Normally distributed now, right? When it is normally distributed, right? When it is normally distributed, it means our distribution should look like this, right? ඔන්න ඔය විදියට යන distribution එක. Right? You know the properties of a normal distribution. Yeah. Normal distribution. Right. Okay. Here what it says. A firm manufactures electric light bulbs that have a length of life that is approximately normally distributed. ඒකයි මේ shape එක එන්නේ. With the mean equal to 800 hours. Mean කියලා කියන්නේ හරියටම අපේ මෙන්න මේ highest point එකට අදාළ යට value එක. Right? The value here is 800. Normal distribution වල ගණන් හදද්දි මතකයි. Right? The mean value is 800. With a standard deviation of 42 hours. Standard deviation value එකක් දෙනවා. Find the probability that a random sample of 16 bulbs will have an average life less than 775 hours. 775 කිව්වොත් to the left side of 800 to the right hand side of 800 what? 800ට වම් මත පැත්තේද දකුණු මත පැත්තේද? 775. Where it should be? අද මොකද කට්ටිය කතා කරන්නේ නැත්තේ? Right? Where it should be, to the left hand side or to the right hand side? Yes, to the left hand side, right? 775, somewhere here. 775, right? To the left of this means this is our cutoff. 775 තමයි අපේ cut off එක. එහෙනම් මෙතනින් මොන පැත්තද අපෙන් අහන්නේ? Right? This part. Right? Find the probability that a random sample of 16 bulbs will have an average life less than 775 hours. Bulb 10න් එකක් අපි අහම්බෙන් ගත්තොතින් ඒ බල්බ් එකේ ආයු කාලය පැය 775ට වඩා අඩු වෙන්න තියෙන සම්භාවිතාවය. Right. Here. What we know? Right? මෙන්න මෙතෙන්දී highest point එකෙන් පල්ලෙහාට ආවට පස්සේ what is the z value here? දැන් මෙයාව common basis එකකට අරගෙන ඉන්න ඕන. Otherwise we can't find the value of what? We can't find the value of probabilities. We can't find the probability values. Right? මෙයාව common basis එකකට අරගෙන ඉන්න ඕන. It means we need to find z values. When I convert this 800 to a z value, what should be the value? Can you remember? Yes, 0. Right? Mean value එකට අදාළ z value එක හැමතිස්සෙම 0. Right? Right? Then I need to find when it is 775, what should be the relevant z value? එහෙනම් x value එක 775ක් වෙද්දී අදාළ z value එක කීයද? That one I need to find. Right? This one I need to find. Right? How have we find the z value? z value එක හෙව්වේ කොහොමද? z value එක හෙව්වේ කොහොමද? z equals කොහොමද හෙව්වේ? x minus මොකක්ද? x minus mu divided by standard deviation. Right? Normal distribution හොයද්දී, right? This is the formula we have used. මේ formula එක තමයි අපි පාවිච්චි කරේ. But now can we use the same formula? Normal distribution වල මොකද්ද කරේ? Population එක ගැන විස්තර දුන්නා. Population එක ගැන මේක එක අවස්ථාවලදී probabilities ඇහුවා. හැබැයි මෙතන වෙනස්. Population එක ගැන විස්තර දෙනවා. හැබැයි ඒ population එකෙන් ගන්න sample එකක් ගැන තමයි අපෙන් probabilities අහන්නේ. Right? What we have learned is, right, population mean and the sample mean we can assume as it is. Right? Both of them are equal. But when it comes to standard deviation, right, population standard deviation is not equal to the, or may not be equal to the sample standard deviation. මේ standard deviation නෙවෙයි sample එකකට එද්දි තියෙන්නේ. එයා කවුද? දැන් අපි ගන්න ඕනේ මොකද්ද? Standard error of mean කියන එක. Right? Now we want to consider this one, standard error of mean. මෙතනදී what we need to consider? First formula or the second formula in this sum? මේ ගානේ විදිහට අපි ගන්න ඕන පළවෙනි formula එකද, right? මෙන්න මේ formula එකද නැත්නම් මෙන්න මේ formula එකද? මෙතන අපි දැන් බෙදන්නේ standard deviation වලින් නෙවෙයි, standard error of mean වලින්. Right? Now we need to divide this one by standard error of mean. Right? Standard error of mean ගන්න පාවිච්චි කරන formula එක මොකද්ද? Formula number 1 or formula number 2? මොකද්ද? Right? Population size එක දන්නව නම් formula number 2, population size එක දන්නේ නැත්නම් formula number 1. අපි population size එක දන්නවද? Right? දන්නවද නැද්ද? Apeksha, Ashani, Avanti, Chami, Dhananjay. Population size එක අපි දන්නවද නැද්ද? 1. Yes. Right? Population size එක. What can you say? We don't know the population size, right? Population size is not given. ගානේ population එකේ මෙන්න මෙච්චර බල්බ් ගානක් තිබ්බ කියලා අපිට ගානේ කොහෙවත් කියන්නේ නැහැ. අපිට දෙන්නේ sample size එක විතරයි. Population size එකක් ගැන ගානේ කොහෙවත් කියන්නේ නැහැ. Right? It means there is what? There is what? Infinite population, right? Population size එක අපි හරියටම දන්නේ නැහැ. Infinite population. Therefore, to calculate the standard error of mean, right? To calculate the standard error of mean, we can use, or we have to use the first formula, right? We have to use the first formula to calculate standard error of mean, right? Standard error of mean. Simply we can say SC. It is standard error of mean. Right. Standard error of mean එක කීයක් එනවද? Right? Standard deviation is given. Standard deviation එක කීයක් කියලාද කිව්වේ? Right? Standard deviation of 42 hours. Standard deviation is 42 divided by the square root of sample size. The sample size is 60, right? So we need to divide it by the square root of 60. Therefore, what should be the standard error of mean value? මෙතන කීයක් එනවද? What should be the answer here? Standard error of mean should be equals to 42 divided by square root of 60. What? 10.5. Right? 10.5. Yes, 10.5. Right. Now we can find the Z value. Right? දැන් අපිට Z value එක හොයාගන්න පුළුවන්. කොහොමද? Z value එක හොයන්න ඉස්සෙල්ලා අපි standard error of mean දැනගෙන ඉන්න ඕන. Standard error of mean අපි හොයාගත්තා. Right? The answer was 10.5. By using that standard error of mean value, we can find the relevant Z value. අපේ දැන් X value එක කීයද? What is our X value now? What is our X value? 800 දී දන්නවා අපි දැනගන්න ඕන කීයදීද? 775 දී. So our X value is 775. Mean value is given 800 divided by standard error of mean. අපි calculate කරගත්ත value එක 10.5. Right? 10.5. So what should be the Z value here? 775 minus 800 equal divided by 10.5, right? Minus 2.3, right? Minus 2.38. This is our Z value, right? Our Z value should be 2.38. Right. Now we have to use the normal table to find the respective Z value, right? Normal table එක පාවිච්චි කරලා දැන් අපිට Z value එක කියන්න පුළුවන්. This is our Z table, right? This is our Z table. We have found the Z value here should be minus 2.38. Then Z value is minus 2.38. Right. අපි 2.38 හොයාගෙන ගියාට පස්සේ අපිට එන්නේ මොකද්ද? Right? 2.38 here 2.3, මෙතනින් 8. This is what we will get. 0.4913. 0.4913 means the value here, right? මෙන්න මෙතන value එක from 0 to minus 2.38. The probability value is 0.4913. බිඳුවේ ඉඳන් ඔය ඍණ 2.3 වෙන තැනට වෙනකන් probability value එක 0.4913. එහෙනම් මෙන්න මේ ටිකට අදාළ probability value එක කීයක් වෙනවා ඇද්ද? What should be the value? How can we get that answer? කොහොමද ගන්න පුළුවන්? Symmetrically distributed, right? Symmetrically distributed නම් මොකද්ද? එක පැත්තක් 0.5 0.5 වලින් මෙන්න මේ portion එක පෙන්නනවා 0.4913, right? 0.4913. Therefore this colored area, the probability of this colored area should be what? 0.0087, right? 0.0087. Yes, 0.0087. Therefore this should be the answer. Right? This should be the answer. Clear? Same as normal distribution, right? Normal distribution ගන්න වගේම තමයි. But where's the difference? Instead of, when finding Z, instead of dividing it by the standard deviation, now we have to divide it by standard error of mean, right? Why? We assume the population standard deviation and the sample standard deviation is not equal. We have to do certain adjustments, right? එච්චරයි වෙනස නැත්නම් ඊටු ටික normal distribution වල වගේම තමයි. Right? Sampling theory. Right? The final answer should be 0.0087, right? That is the probability value. Right. Clear? Example number 2. Example number 2. Example number 2. මොකද කියන්නේ? For a group of 1,600 employees of a firm එක employees ලා 1600ක් ඉන්නවා. IQ is approximately normally distributed with a mean of 105 and a standard deviation of 20. Right? Employees ලා 1600ක් ඉන්නවා. ඒක එක්කෙනාගේ IQ level එක measure කරලා තියෙනවා. Right? Based on those data they have given us, the mean IQ level of an employee is 105 and there can be a deviation of 20, right? Standard deviation of 20. It is known from experience that for a particular job in the firm, only persons with IQ of at least 90 are intelligent enough for the work. Right? Again, it is known from the experience that for a particular job in the firm, only persons with IQ of at least 90 are intelligent enough for the work. IQ level එක 90ට වඩා වැඩි නම් විතරයි එයාට job එක හරි විදියට කරන්න පුළුවන්. IQ level එක 90ට අඩුයි කියලා කියන්නේ එයාට මේ company job එකක් කරන්න අමාරුයි කියන එක. Right? But those with IQ above 115 soon become unhappy with the work. Right? IQ level එක අඩුම 90ක්වත් ඕන මේ කම්පැනි වැඩ කරන්න. හැබැයි IQ level එක 115කට වඩා වැඩි අය කවුරුවත් මේ කම්පැනි එකේ ඉන්න කැමති නැහැ. Right? They will go for a better job. Find the probability that from a random sample of 10, මෙතනින් තමයි වෙනස් වෙන්නේ. Random sample of 10, right? Employees who will suitable for that job. Employees ලා 10ක sample එකක් ගත්තොත් මේ 10 දෙනාගේ sample, right? Find the probability, right? මේ 10 දෙනාගේ sample එකෙන්, right? මේ කම්පැනි රස්සාව කරන්න සුදුසු කී දෙනෙක් ඇද්ද? එහෙම ඉන්න පුළුවන් සම්භාවිතාවය කීයද කියලා අපෙන් අහනවා. Right. Right. Normally distributed. IQ is approximately normally distributed. Approximately normally distributed means we can have an idea of the shape of it. Right? Distribution එකේ shape එක ගැන අපිට idea එකක් ගන්න පුළුවන්. Right. It should be something like this. Right? Approximately normally distributed. Right? Approximately normally distributed. Right. What is the mean value? With the mean of 105. Mean value is 105. Mean value. මෙන්න මෙතන value එක 105. 105. And a standard deviation of 20. It is known from the experience that for a particular job in the firm, only persons with IQ of at least 90. 90 Q thing somewhere here, right? To the left of mean value. 90. 90ට වඩා වැඩි නම් විතරයි මේ ජොබ් එක කරන්න පුළුවන් වෙන්නේ. 115ට වඩා වැඩි වුණොත් කවුරුවත් මේ ජොබ් එකේ රැඳෙන්නේ නැහැ. Right? වෙන ජොබ් එකක් හොයාගෙන යනවා. So these are the cutoff points. එහෙනම් අපෙන් අහන්නේ මෙන් IQ level එක මෙන්න මේ range එක ඇතුලේ තියෙන සම්භාවිතාව. 10 දෙනෙක්ගේ sample එකක් ගත්තොත් right? IQ level එක මෙන්න මේ range එක ඇතුලේ තියෙන සම්භාවිතාවය මොන වගේ වෙයිද? That is what we need to find. Right? At the mean value, the Z value is 0. So we need to find at 90 what should be the Z value, and at 115 what should be the Z value. Right? 90 Z value එක වෙනම හොයන්න ඕන. 115 Z value එක වෙනම හොයන්න ඕන. So we need to find the probability, right, area here. This is the formula we are using to find the Z value now, right? Because this is associated with the sample, right? Therefore, the first thing we need to do is we need to calculate the standard error of mean, right? The standard error of mean calculating in on. What is the formula I need to use? Formula number 1 or formula number 2? එකද දෙකද? What is the formula we need to use? First one or the second one? Standard error of mean හොයන්න ඕන. First one or the second one? Why it should be second one? A second one වෙන්නේ? Right? A මෙයා වෙන්නේ. Why we can't use the first one to find the standard error of mean, right? This one. Why it should be this one instead of this? How can we decide that? Yes, based on the population. In example number 1, right, the population size was not given, right? Population size was not given in example number 1. But in example number 2, they clearly say this is the population size, right? Or right, we can see directly the population size here. Population size se අපිට බලා ගන්න පුළුවන්. What is the population size here in example number 2? Right? The population size is 1600. මේ 1600න් තමයි මේ 10 දෙනාගේ sample එක ගන්න. එහෙනම් අපි sample size එකක් දන්නවා, population size එකක් දන්නවා. Therefore, if there is a finite population, we have to use this formula, right? The second formula, right? Here, if we apply figures here, how it should be. Figures apply करती कोहमद देनी, right? The standard deviation value is given, that is 20. Simple n के लिए क्या है sample size से कर, sample size से कर गाना किया ना, right? Yes, sample size is 10. Capital N के लिए क्या है मुकाद, capital N के लिए क्या है population size से कर given 1600, right? 1600 minus simple n. Simple n means the sample size minus 10, right? Divide by capital N minus 1. Capital N means the population size 1600, the square root value of this. Should be the answer here. 20 divided by square root of 10, right, into square root of open brackets 1590 divided by 1599, close the brackets. 6.3067. Okay, then 0.3067. Is this correct? Right, 6.3067. Yes, right. මේ online session එකට join වෙති මොකක් හරි error message එකක් හරි මොකක් හරි ආවද? මොකක් හරි restriction එකක් ආවද online session එකට join වෙති? join වෙච්ච එකෙන් අහන්න. එහෙම මොකක් හරි ආවද? Right? No. People, them are facing a bit of issue. Right, okay, fine. Right. Okay. Here we have found the standard error of mean as 6.3067. Right, after finding the standard error of mean, now we can find the Z value, right? Right, Z values first we will find, right, at 90, right? When the IQ level is 90, what is the corresponding Z value? right? Therefore, x value, right? 90 minus mean value. Mean value is 105 divided by standard error of mean, which we have found as 6.3067. Right? So there is a current failure. Right? 6.3067.